Hello, everyone. Welcome to another coding club at the Fledge. We got Bob with us today and two new people. Marcel's with us for the first time. What's up, Marcel?
How you doing?
Doing good. Doing good. And you're down in the studio, right?
Right.
We got some surprises for people in the studio, don't we?
Oh, a lot.
Yeah, it looks really good. And then David, I just want to point out you're muted.
Oh, I know.
And yeah, okay. And David's with us. Man, I don't know the last time I've seen you face to face.
About 3 years since I've been able to really stop by the Fledge. I remember I picked up a Fledge shirt. And you guys just moved to that. It was a little bit after you moved to that Lansing location, I think it was, because I remember coming and seeing you in Grand Ledge. I like the Grand Ledge name better because it kind of rhymed, but still love the Fledge.
Yeah, well, thank you. So today, everybody on the screen is going to contribute a little bit, and we're going to build this coding club bigger and bigger as we go. So Bob is going to talk to us about a project he's been working on real quick. So take it away, Bob.
Okay. I've been working on a project to get a computer that has enough power so you can do some things, learn how to code. You could do schoolwork on it and everything else. But I wanted to do it as inexpensively as possible. And the whole gist of it is to get it to people that don't have a computer to begin with and would like to learn how to code. And, you know, there's a financial burden. They don't have money to throw around for this kind of stuff. So that's sort of where I'm coming from with this. And I figured out the different parts that I needed. And when I added everything up, it came out to $111.11. $111.11. There you go. So that's the whole. In fact, right there, Jerry, if you scroll back up a bit, yeah, you can see go down just a little bit. I probably should have had it on my screen. Go down a little further. I want to show them here's the price. Raspberry Pi 4, which has a quad-core processor, 64-bit, that cost, and 2 gig of RAM. Now, I know gamers don't think 2 gig is much, but it's enough to run a whole lot of stuff. Get a monitor from MSU Surplus for $20. And then the rest of the stuff, you know, you need some adapters to hook up to the HDMI, power supply, so on and so forth. And when you add everything up, you know, this first pass, it's 111.11. So that's where the name came from. And so Jerry and I are going to probably have to do a little bit of figuring to figure out just how we're going to do this. I'm going to self-fund this for a while, but if we get 100 people that want one, I'm not part of the landed aristocracy, but when my $600 comes, that'll probably go into the pot for this. So.
All right. And I like the website. It's it's straight to the point.
Yeah, I had to get it up, so that, we had some place to go, but that's it.
Yeah. All right. So now, you ready, David?
I am ready. But I did want to say that's a really cool idea to try to build a full system all on a SoC computer. I don't know if you've looked into them, but I'm a huge fan of SoCs and Raspberry Pis. I have a Raspberry Pi cluster myself. But recently I've been looking at a product from Hard Kernel called the OC2, I think it is. Okay. They actually have x86 processors on a SoC chip, so you can run like Windows on that and actually some modern applications as well. They do have some other options that are very comparable to the Raspberry Pi, such as the Big Little processor. So you get the quad core processor with the Snapdragon, but then there's another 4 cores that are more like efficient and off, like for your background tasks. So they're
Okay.
highly power efficient. Something to look into maybe while looking at those. There's some good products over there at Hard Kernel.
Hard kernel. Okay. I'll check that out. Thank you.
Yep. And I can't see if I'm actually streaming now or if my screen is visible. I'm just assuming it is. I'm going to get
Yeah.
started on what I'm doing.
There you go.
So recently I got a Christmas present. It was an Xbox 360 Connect. Now, I'm a geek, so this was something really cool for me. A lot of people would be like, oh, what are you going to do that? Play video games? I actually don't own a console. I hooked this into my computer, and as you can see, I got their documentation or their examples up here. There's a lot of cool stuff I actually can do with this. There's audio processing. They have a Fusion SDK that allows me to do structure for motion, kind of reassembly of multiple pictures into like a 3D space. That usually uses camera matching when you're talking about structure for motion. But the Kinect has something very unique. It actually has an infrared sensor. And it's very unique how it pumps it out. But I'm going to just jump in and kind of show you some of this. So I'll start with something real basic. And we'll go through. That can't do that one. I don't have the XNA installed. So one cool thing you can do with this is face tracking. I hope this is set up. Yep, that is running. All right, so I can see what the camera sees now. It's going to take a second to kick in, and this headset might make it a little weird. But it actually kicks in.
Oh, wow.
One cool thing I thought about this is I was thinking about recommending this for a friend of mine that does YouTube channels, to be able to make a animated character, because as you can see, the mouth mesh, is actually moving. And if I lift my eyes, you can see the mesh move up there too. So it has some facial expression that you could put into a live model for character animation. So that's one really cool thing that's got me really excited about the Kinect. This is the 360 version too. There you could get the Xbox One version. They're all discontinued now, but they're really fun to play with. The newer version obviously has a better camera and better sensors. So as I said, this uses infrared light. I haven't actually ran these examples, but this is the light spectrum that it's putting out, and it uses this light to create like it's able to determine the distance each pixel is from the camera. So as I move back, you can kind of see it, and the background is darker. It only goes so far. So it uses the intensity from the light as well as the coordination of where the light is in the focal view of the camera to actually determine some things, which I haven't talked about yet too much if I did. So that's kind of how it works. The really fun stuff, I really want to get into the fun stuff because I got some stuff in my bed laid out that we can scan. So one of the real fun things is it can detect a 3D environment, and you can reconstruct the 3D environment. So now I've picked up my Kinect. I'm going to start up this. We'll do I think it's this example. Not full screen this. No, that's not the one I wanted. We'll just do this one. This one I've had good success with. Except for when my something's got it locked on. No. So that might end my demo unless I restart my computer, because it says another application has it. That means the other application does not close its access to it, and I can see the infrared camera is still on even though I closed the other application. That's not very good.
Well, do you have like a previous project that you already scanned or something that you want to show?
I did
Or
not save any of my scans. There actually is this tool here, the Kinect Studio. So when I run this, actually I might be able to, I haven't tried this yet. So it sees the camera running. There's actually an application on it, or else it wouldn't be displayed. I technically could.
I don't know.
What this part of the application does is it lets you record the motion. So right now I click the record button. It's actually recording the pictures and the depth map right alongside each other. When I stop it, you'll see this. This is usually used for debugging your application. So you can record a scene and then you can replay that scene pretty much as a virtual camera back to your application. I haven't actually done that yet, so I don't know if that'll work. I just want to have that camera be accessible again. So I don't think I will be able to demo anymore unless I restart my computer. And that's probably because that one application is the one that was, I hadn't ran before and didn't know it wasn't going to close the camera right, because
Okay.
I've had that happen a few times.
Well, do you want to restart, and we'll
restart will
bounce
take
over
me-
to Marcel?
Yeah, restart will take me 3 minutes, and I can continue after that. And that's really where it's about to get fun too. So I'm really upset that it stopped there. But
All right,
I'll
then
reset
let's.
and hand it off to Marcel.
All right, so you'll disappear for a minute. I'll watch for you to come back. Marcel, have you tried to share your screen yet?
Oh yeah, I got it. Give me a second. I gotta make some arrangements.
Okay. Sorry, I was. What do you think about that demo, Bob?
I'm intrigued. I've got a Connect kicking around here somewhere. I'm going to have to dig it out. So I'm really curious about this.
All right. I have a Connect somewhere as well that I would also like to dig out, and because this looked like super easy, right? You still hearing me, Bob?
Yeah, I can hear you. And I'm assuming from David's initial talking about it that it's pretty straightforward, but I'm sure with anything you'd have to play around a little bit and get used to it. I've got a 3D scanner for, to make, take a picture of a model. It's a completely different setup. It's got two lasers that point toward a table that spins, and it takes a picture every, about a 16th of a turn or whatever. And then when it's all done, it will stitch them together, and then you have to do a little bit of cleanup, but you can, do smaller objects. But this thing sounds like you could do some pretty good size stuff too.
Yeah. I've always wanted to connect one to one of the smart locks. So if you walked up to the Fledge, it would read your face, recognize it, and know if you were authorized to unlock the door.
Okay.
Yeah, I'd like to do that someday.
A lot of possibilities.
Yep. Maybe David will be our champion for that.
All right.
So we also lost Marcel in this process, and we lost pretty much all of our viewers.
What?
Yeah, we're
Is
down
it
to
something we said or didn't say?
It was something that we didn't say.
No.
I don't know what that was. Maybe I should have said Happy New Year to everybody and been more kind in the beginning.
Yeah, come on, Jerry. Jeez.
So we got David back in.
Here we go.
We lost Marcel in the process.
Oh no, it's one of those days.
Yep. But with you coming back, your screen's getting shared. Do you want me to throw that up there now?
Yeah, sure.
All right.
Ooh, all right.
All right. So this is what it's giving me in real time, and the application I'm using. Which one did I launch? It was actually. Let me just look over here real fast. It was the Connect Fusion Explorer, the WPF version. So you can click this little reset button, and you see it start scanning again. If I move, you see the camera kind of moves. That's generally not what you want to do. Like generally, what you do is you set it here, and then you'd rotate around, and it's actually filling in the parts that it misses, other than where I'm moving and I kind of offset. It's using camera matching. There's actually accelerometers for the G-forces applied to this inside here. So it does have XYZ to help it with its camera position. But I've laid some things out on my bed. I hope you can see them with my web camera. as well, so you can kind of see me doing this. But I'm going to reset this, and you can see it's kind of scanning them, and it can see that there's actually dimension there. As I go around, it'll fill in more and more detail, kind of. Sometimes you got to go back or forward so it can get that point density. But you can see I have this little ghost thing, a 3D part that I printed for a hexagonal shelf, and you really can't see it. This piece here, this is part upgrade part for my 3D printer to put a mount on the front of it, and then a little cologne bottle. And my banjo ukulele behind it. It's one of my favorite things. But I think this is really cool. Some other things you can do in this is you can adjust your threshold. So I can put this down to 1 meter. As you can see up in the top right part of the screen, you can see that when I move this slider down, it's not looking as far. So you can make it so you don't see stuff in the background. I can reset the reconstruction, and then it's only near field stuff. So it's not getting the back wall or anything like that when I do a new construction. From this, you actually can export an STL file. So I could scan my banjo ukulele, and then I could print it on my 3D printer. My printer doesn't print that big, but this is one really cool thing you can do with it. And I was thinking about using this for robotics, for creating a robot that can be spatially aware. This would be similar to the technology that they're using on the Google cars and stuff like that. Actually, it's similar that it produces the same kind of effect, but it's using a different technology. This is actually using infrared. The Google cars and more advanced 3D scanners, they actually use LiDAR, or some of them, the new Kinects actually use a different type of infrared, I believe. So Xbox 360 Kinects here, these actually, if you have multiple of them, the infrared they produce can conflict with each other. And then the new ones, the Xbox One version of them, you can have multiple and they will not. I just love watching this reconstruct right in front of my eyes. Like, that's my wall with my 3D printer over there. It's just really cool to do and then watch it fill in. I've enjoyed this a lot. So a few other things, or one other thing. It's the same thing, but this is a product that was actually made for actually doing the 3D scanning. And this is Reconstruct Me. This is a non-commercial license. I'm obviously not using it here commercially because I'm a huge geek. I'm not looking to make money. But now you can see it's actually adding the color and stuff. As I go around, the green areas are areas where it has low confidence of what it is there, but then it'll fill in once it has higher confidence. So if I get back around here, this only does like a minute's worth of scanning and then it automatically stops. And if I move too fast, it will lose its position and then also and not work as well. So I'm going to go up and click that finish button. Oh, I lost my geometry. So I can move back to a position and kind of get it, but we're not going to do that. But, there's a little scan of, let me maximize this, of what I laid out at my bed to kind of give us a little test. It's not super accurate, but if you have a model that stays still and you mount this in a secure location, like in my chair here, if I had this mounted and I stood still and somebody gave me a good push and spun me around, that would work perfectly for doing a 3D scan of this, and then I can export it as a 3D model. So that's kind of about it. There's some more stuff you can do, such as the motion tracking. Like, they have a little shape game. I don't need XNA, but like some of the ones I looked at previously were these skeleton basics. I don't have the thing on there, and it's not showing me the output.
What's the website you're on right now, David?
I'm not currently on a website other than Facebook and our broadcasting studio. This is the Connect Windows Developer Toolkit 1.8.
Okay.
You can download that right from the Microsoft website, as well as the Connect Fusion SDK. And the Fusion SDK is what I'm going to be exploring. So I can make my own custom applications. But I recently got this, so I'm kind of just digging in the example code right now, just trying to get my bearings in, how this works and how you actually have to, work with the Fusion SDK, which is pretty complicated if you ask me. You have to, you'll get the inputs, but you have to kind of manually map the inputs. They have functions that will help you like generate the mesh or run those algorithms and stuff. But some of the times you have to recreate like, the pixel array or the depth array and stuff like that, or iterate through those to interpret them in the way that you would like. So it's pretty advanced. You got to kind of know what you're doing with 3D space to use it, but they do have functions to help you with the reconstruction of volume, because it actually generates a voxel. That what we're seeing actually when it was running live was a voxel. Minecraft is a voxel world. It was just really high detail, so there's small voxels. And then when it's done, it takes those voxels and it creates like vectors to create a flat mesh that's more traditional for CPU consumption or GPU consumption.
All right. Hey,
Yeah.
Another quick question. You just are plugging your Connect into a USB, right? And I think it has a power cord, maybe?
Yeah, so I got the Connect, and to my dismay, what's actually at the end of the Connect is not USB. It looks kind of like USB, but it's not. You have to get a little power adapter, which cost me like $9 on Amazon.
Okay.
You plug that in, you plug it into the wall, and that has a tail that comes off that you plug into your USB in your computer. It's pretty plug and play, to be honest. The one thing I haven't been able to do is actually use it as a webcam. So it doesn't pick up naturally as a webcam. I don't know if there's software for it yet, or if I'll have to make it to make a virtual webcam out of it. But that would be something I'm interested in. One other feature about it that I was totally surprised. There's a motor in the Xbox 360 Connect that tips it up and down. Just kind of weird. I didn't think it had one. I never thought that, but yep.
Well, this is very awesome, very informative, and very much making me motivated to go dig through boxes till I find that Connect we used to have.
Right, two's better than one. You can use two at the same time. Actually, with the 360 Connect, you can use up to four at the same time. But like I said, they do have interference with each other. But it might make a full scan a lot easier, depending on their
Pretty
angles.
awesome. Marcel's going to be digging through the boxes all night now. What'd you think, Marcel?
Oh yeah. I give him an 8.
Yeah, really.
No shade.
So, you having problems with your sharing your screen?
Nope. I fixed it. I sort of kind of did. I think. Let me try it.
Well, let's see it. I'll put it on screen once I see it. So, all right, there you go.
All right.
Yeah. So this is I mean, this is pretty much a manual that like I'm creating and learning like as I go. So I don't know what this is. But anyway, so I started off printing. I know some people say like it's a lot, because it's like, oh, you print, but like, like when people start off, I want them to get the hang of it instead of just like jumping straight to the chase, because like some people won't understand the loop, like, off the back. You got to kind of break it down to some people that, you understand. But yeah. So,
he's talking about me. He's talking about me with all the print statements because I told him about the triple quotes.
Yeah, the triple quotes was great advice.
I mean, I forgot about. I mean, I still,
It's good to give it in bite-sized chunks to a new developer, though. I do agree, because if I would have thrown the triple quotes and all the language features at somebody, they would be overwhelmed.
Scare them.
Yeah. See, I like. I bet we all learned how to code in our own little different ways too.
Mm-hmm.
Bob was reading books. I was just plagiarizing as much as I possibly could, and David was probably, cascading engineering. No, I don't know.
To be honest, the approach I took was I started college and then I got an entry-level programming job, and I quit college and I faked it until I made it. And I Googled a lot. Like,
yeah,
it's a big running joke in the computer programming circles. Like, he's just really good at Google.
So how Marcel learns is going to be different from all of us and how he walks through that. How long you been trying to do this, Marcel?
Almost 2 weeks now.
Oh, wow.
Oh, you're doing good.
Yeah.
Yeah.
And what were you writing when we first started talking about code? What were you trying to do?
Oh, print.
No. Not this. When we were doing the bots.
Oh, so Bitcoin. It was like a Bitcoin bot. So like Bitcoin mining type, and this. So I had formed like a group, and what I did is I put a bot in that group, and I like had multiple bots, and I gave them variables like I gave them functions. It took me a while to learn functions like variables and stuff. I'm bad at math. Don't judge me. But yeah. Anyway, like I'm losing it.
Nobody's bad at math. Somebody just told you were bad at math.
Yeah.
But no. So let's go back and you want to execute the code for your.
This isn't code to like execute. This is a manual. This is like me like breaking it down like character names and like list functions, like like standard variables, functions, printing variables, string, like this. It's hard to explain really, but you just kind of.
It's a beginner learning reference point. It's really good to have all that in one place where you can kind of come and refer to it. Like similar to when I get on a coding project, like I feel code dumb. Like I don't remember how to code all of a sudden starting a new project. But when I have some code to look at, it like comes naturally. So having references is really good to remember those function calls or just how to access something. Maybe there's a function that requires an array and you forgot it. And then you look at your reference. Oh yeah, I needed to make it a byte array. So I think this is really cool.
Spot on. But, you got to build in a basic calculator. Kind of.
All right. You feeling good about where you're at?
Oh, yeah. Very.
I'd say that's pretty good if you've only been at it a couple of weeks.
Mm-hmm.
I mean, YouTube. All day
stuff out there.
But it's not really impressive. It's just kind of something to start off with and try to introduce everybody to what I'm doing and I'm working on it, but it's kind of.
I'm impressed, Marcel.
Yeah,
I'm glad you're doing this. I'm glad you're working through this. I know you're going to be executing some code here soon, in front of everybody, and hopefully you'll be the host, and I can just go home at 4:00 every day. So, with that said, Marcel, great job. Thank you very much. I'm gonna take your screen off, or your other screen off this view. And thank you, Marcel, for presenting. Thank you, David, for your presentation. That is very intriguing. And Rob, thank you for the work in the community that you're doing to try to close that digital divide. And it's working. It's going to work.
Yeah,
we're going to make our community stronger. So with that said, everyone stay tuned next week. Let us know if you want to present something, and we'll see you next Monday at 5 for Coding Club at the Fledge.
All right.
All right.
Bye.